Venus is a beautiful, elegant planet, seemingly very calm and almost tranquil on the surface, wrapped in a soft cloud like a blanket. From an outsider's perspective, it's clear why it's named Venus, the Roman god of love. But go beneath the cloud layer, and you'll find quite the opposite. Scorching temperatures, volcanism, and a crushing atmosphere are what you'd actually find on the surface. There are few places in our solar system more deadly, and its acid-laced environment makes visiting next to impossible. So, what do we know about this beautiful yet hellish planet? More than you might think. Hi, I'm Alex McColgan, and you're watching Astrum. Join me today as we delve into what makes this planet so unique in our solar system. Get ready to find out everything you could want to know about Venus. Let's start by stepping back a bit to see where this planet fits into our solar system. Venus is the second planet from the Sun, and it's our closest neighbor. Its average orbital radius around the Sun is 72 cents, or roughly 108 million kilometers. It doesn't vary much at all from this mean orbital radius, as it's the planet with the least eccentric orbit, orbiting nearly in a perfect circle. At Venus' closest approach to us, it is the nearest of any other planet, being only 41 million kilometers away. Interestingly, though, this is not when it's brightest in our sky. When Venus is closest to us, we only see its night side since it's between us and the Sun. It is still visible, though, as sunlight refracts through its atmosphere. It's actually brightest when it's a thinner crescent shape in the sky, and when this happens, it is the brightest object we see at night after the Moon. As such, Venus is commonly misreported as an unidentified flying object. U.S. President Jimmy Carter reported seeing a UFO in 1969, which later analysis suggested was probably Venus. Countless others have mistaken Venus for something more exotic due to its startling brightness. I recently had the pleasure of looking at Venus through a telescope, and remarkably, its crescent shape was very visible. With Venus orbiting between us and the Sun, you may wonder if it ever eclipses the Sun from our viewpoint on Earth. The answer is yes, but surprisingly, very rarely. Transits happen in pairs, with the pairs being 8 years apart, but each pair only occurs once every 100 or so years. The last transit was in 2012, but if you didn't see that, I'm afraid the next one won't be until 2117. The reason for this rarity is that Venus' orbital plane is not exactly the same as Earth's. Also, Venus only catches up with Earth every 584 or so days. These two factors combined ensure that, although a spectacular and predictable sight, we'll probably only ever have the chance to see it once or twice in our lifetimes. All the planets orbit anti-clockwise around the Sun, and in this, Venus is no different. But unlike all the other planets, it rotates clockwise, or in other words, in a retrograde rotation. Not only that, but it has an extremely slow rotation, taking 243 Earth days to complete one full turn, slower than any other planet. This makes a sidereal day on Venus longer than a Venusian year, which lasts 224 Earth days. A sidereal day, if you remember from my recent Mercury episode, which you can check out here if you missed it, is one full rotation of the planet. However, because of this retrograde rotation, a solar day, from sunrise to sunrise, is considerably shorter, just 117 Earth days. This means you'd only experience just under 2 days on Venus in 1 year. To put this slow rotation into perspective, at the equator, Venus is only rotating at 6.5 kilometers per hour. This slow rotation makes it the second most spherical object in the solar system, after the Sun. It is unclear why Venus rotates backward compared to the other planets, but it could be due to a massive impact with another object billions of years ago, tidal locking with the Sun, or tidal effects on its atmosphere. Its mass and size are very similar to Earth's, which is why it's often referred to as our sister planet. Venus is one of the 4 inner terrestrial planets and is a rocky planet. Its diameter is slightly smaller than Earth's at 12,100 kilometers compared to Earth's 12,740 kilometers, and its density is 5.3 g/cm superscript 3 compared to Earth's 5.5 g/cm superscript 3. This means the gravity on Venus is only slightly weaker than on Earth, with a surface gravity of 8.9 meters per square second. But this is where the similarities end. On the surface of Venus, the atmospheric pressure is 92 times greater than on Earth, equivalent to being 1 kilometer underwater in Earth's oceans. The reason for this is that Venus' atmosphere is 93 times denser than Earth's. With all that gas packed into a slightly smaller space than Earth, you can understand why it's so dense. The atmosphere consists mainly of CO2 gas, and combined with sulfur dioxide clouds, it creates the strongest greenhouse effect in the solar system. The result: surface temperatures of 462 degrees Celsius on average, hotter than Mercury. Even though Mercury is closer to the Sun, Venus only receives 25% of the solar radiation that Mercury does, but because Mercury lacks an atmosphere to retain heat, Venus ends up being hotter. Even at night and at the poles, the temperature remains fairly constant. Venus truly is a cooking pot. It absorbs heat and, like a thermal flask, retains it. With an axial tilt of only 3 degrees, seasonal changes in temperature are minimal. Wind speeds on Venus' surface are low, only a few kilometers per hour, but due to the dense atmosphere, even a gentle breeze applies significant force, moving small rocks and dust across the landscape. However, at the cloud tops, winds reach 300 kilometers per hour, circling the planet every 4 to 5 Earth days. This rapid motion makes Venus appear to rotate much faster than it actually does. The clouds on Venus are highly reflective, allowing only about 10% of sunlight through. Since they cover the entire planet, they obscure any visual view of the surface from space. These clouds also produce lightning, though less frequently than on Earth. Recently, scientists discovered that Venus has a large vortex at its south pole, much like Saturn. Unlike Saturn's many storms, Venus has just one, sitting at an altitude of 59 kilometers, just above the cloud layer. Interestingly, at about 50 kilometers up, the pressure and temperature on Venus are similar to Earth's. Even the gravity would feel Earth-like. The only problem is the air itself. But with an airtight plane or floating station, the conditions would actually be quite tolerable. Back on the surface, we have real photos of Venus, thanks to the pioneering efforts of the Russians in the 1960s to 1980s. The Venera 7 probe, in 1970, was the first to land on another planet and send back data. Venera 9 sent the first image of Venus' surface, and later missions captured even more imagery and data. Using radar, we've now mapped Venus' surface in high definition. It is covered in volcanoes, 167 of which are over 100 kilometers in diameter. However, Venus lacks plate tectonics, meaning its crust is much older than Earth's. Scientists believe a massive resurfacing event occurred 300 to 600 million years ago, covering most of Venus in lava. Lastly, Venus doesn't have its own magnetic field, unlike Earth. Scientists speculate that Earth's magnetic dynamo may have been kickstarted by a massive impact, whereas Venus never had such an event.